Hello, welcome back to my recorded classes. This video we are discussing a topic from the course Mathematics for IT, the machine number. Okay, so before starting the topic, please subscribe my channel for getting more recorded classes from this chapter. Okay, let us start the topic. Section number 1.2, the machine number. Okay, and this section we are studying 64-bit binary digit representation of a number. Okay, how can we represent a decimal number into 64-bit binary digit representation? Okay, so 64-bit, see here I am given one example. In 64-bit, first bit, okay, first bit we are calling sign indicator. We are representing S, okay, by the letter S. One bit, okay. So when we are saying the sign indicator, if 0 is the first number, means number should be positive. Decimal number should be positive. If first bit is 1, then the decimal number should be negative number. Okay. Now remaining 11 bit, okay, 11 bit we are calling exponent or characteristic part. We are using the letter C for representing the second part, 11 bit. And next 52 bit we are calling fractional part or mandisa. Okay, we are using 52 bit. So totally we have 64 bit, okay, representation. This is the IEEE 754 standard format for representing a decimal number in a 64-bit binary digit. Okay, so 64-bit binary we are classifying in three parts. One is sign indicator part, 1 bit representing small letter S. Then next 11 bit we are calling exponent or characteristic part representing C, and next 52 bit fractional part or mandisa. Now see, from this 64-bit representation, if you want the decimal number, whatever the number you entered in your computer, okay, we can use this rule for finding the decimal number. That means the floating point decimal number equals minus 1 power S multiply 2 power C minus 1023 multiply 1 plus F. Okay, using that rule you can find what is the decimal number you entered in your computer. So minus 1 power S, S means the sign bit, sign number, and multiply 2 power C. C we are getting from this 11 bit characteristic part. Okay, we need to change that into decimal number. I will tell you how to change when we are doing questions. And multiply 1 plus F. F means the fractional part. This 52-bit part we need to change into decimal number. Okay, then when we are multiplying these three terms, we will get what is the floating point decimal number entered in your computer. So this is the basic idea of the 64-bit machine number. Okay, now we will go to the questions. Now before starting the question, make sure you are using this calculator for the computational purpose or calculation purpose. Okay, because most of the topic I am explained by using this calculator. Especially you can just note the calculator function fx 991 es plus. This is the best calculator for doing numerical questions. Okay, so we can familiarize the buttons one by one when we are doing questions. Okay, now we will go to the first question. Exercise 1.2, question number 1. Find the decimal equivalent of the 64-bit floating point machine number. Find the decimal equivalent. I am just underlining that word, decimal equivalent. Decimal equivalent means we need to find the decimal number, okay, of the 64-bit long floating point machine number. One 64-bit machine number is given, correct? First bit is 0, next 11 bit is given, characteristic part, next 52 bit is given. Okay, so we need to find what is the decimal number representing the 64-bit binary. Okay, so we will start here. We can see the first bit equal to 0, correct? So the sign bit S equal to 1. 0, s equal to 0. Now s equal to 0 means we know the number should be positive number, correct? As I told you before, number should be positive number. Now we need to change in the characteristic part into the decimal and fractional part into the decimal. Okay, so I will explain here how to change the 11-bit part and 52-bit part into the decimal number. So you can see this 11-bit part first, characteristic part. First we are representing, marking the position of each bit. For example, characteristic part we are taking this direction. Okay, characteristic part starting from the bit 1. Here the first number is the 0th position, then 1 position, second, third, 4, 5, 6, 7, 8, 9 and 10th position. Okay, so totally we have 11 bit, but we are starting always from 0. That is why totally 11 bit starting from 0. 0 to 10 means 11 bit. Okay, now the fractional part we are giving the position like this, starting this direction, minus 1th position, minus 2, minus 3, minus 4, minus 5th position, minus 6th, minus 7th position, both are 0. And this is the minus 8th position, minus 9, minus 10, minus 11, minus 12th position. Okay, mostly I am highlighting the 1 bit. Okay, first one number, and these are all 0, minus 13, minus 14, minus 15, like that. Last will be minus 52th position, because totally we have 52 bit in the fractional part. Okay, so we are marked the position of the characteristic part numbers and fractional part numbers. Now we are converting this number into decimal number. Okay, so how can we start here? See, first we are doing characteristic part here. So start from this number. This is 1. 1 multiply 2 power position of the number. What is the position of the number? That is 10, correct? So 1 multiply 2 power 10. Okay, you know how to change the binary number into decimal number anyway. Okay, you can see 1 multiply 2 power 10 plus, okay, 0 number no need to write, because 0 multiply 2 power any position means that will be 0, correct? 0 multiply means, so highlight on the 1 bit numbers. Okay, so 1 multiply 2 power 10 first, then here 1 is coming here, you can see. So that 1 multiply 2 power position of that number is 1, plus here you can see 1. So 1 multiply 2 power position of that number is 0. Okay, so this is the way to change the binary number into decimal number. Okay, now same way you can write the fractional part also. What is the fractional part here? See, this is the first one here. So 1 multiply 2 power position of the number is minus 1. Okay, plus next one is here, 1 multiply 2 power minus 3, correct? 1 multiply 2 power minus 3, plus next one is here again, 1 multiply 2 power position of the number is minus 4, plus 1 multiply 2 power minus 5th position here, then minus 8th position, 1 multiply 2 power minus 8, plus here minus 12th position, 1 multiply 2 power minus 12. Okay, I hope you understood that one, how we are changing. Now when we are writing, it is not necessary to write this one. You can write like 2 power 10 plus 2 power 1 plus 2 power 0 only, because 1 multiply 2 power 10 means same 2 power 10, correct? So that you can save your time. Okay, so you can enter your calculator also same way, 2 power 10 plus 2 power 1 plus 2 power 0. Okay, same way in the characteristic part also you can write only 2 power minus 1 plus 2 power minus 3 plus 2 power minus 4 plus 2 power minus 5 plus 2 power minus 8 plus 2 power minus 12. Okay, it is easy to write like that. So first characteristic part we are calculating by using the calculator. Okay, you will get 1027 equal 1027. That is the decimal number representing that 11-bit part. Okay. Now same way characteristic part we are changing into the decimal. So we can check by calculator this number equals. Enter that number in calculator. 2 power minus 1 plus 2 power minus 3 plus 2 power minus 4 plus 2 power minus 5 plus 2 power minus 8 plus 2 power minus 12. So that you are getting 0.72290003906. Okay, 3906. So this is the number representing the fractional part. Okay, now we are answering our question. What is our question actually? Find the decimal equivalent of that 64-bit machine number, correct? So we are studied already the rule here. Decimal number equals, okay, decimal number equal, what is the rule? Minus 1 power s multiply 2 power c minus 1023 multiply 1 plus f. 2 power c minus 1023 multiply 1 plus f. So equals, okay, we can apply minus 1 power s, okay, we are written only s is 0, multiply 2 power c number we are calculated characteristic part 1027 minus 1023, okay, 1023 multiply 1 plus f number. What is the f number here? 0.7229003906. Okay, 3906. Now we can calculate this number. So when we are calculating, no need to enter this one in your calculator, because minus 1 power 0 means only meaning is number is positive. Already we are written here on the top. Minus 1 power 0. Power 0 means number will be positive. Power 1 means number will be negative number. So we can write here minus 1 power 0 means positive. The remaining part fully we can enter one time in your calculator. Okay, so we will get the answer 27.566, okay, 566,40625. This is the decimal number representing that 64-bit machine number. Okay, decimal number representing that 64-bit machine number. I hope you understood this question. Okay, so we will practice more questions. We will go to the next question now. Question number 1b part. Question number 1b. Find the decimal equivalent of the 64-bit long machine number 1. Okay, first bit is 1. Now next 11 bit is given. Then next 52-bit part also given. Okay, we need to find the decimal equivalent or decimal number from the question. Okay, so again we will start from s, the sign bit. Here s equal to 1. S equal to 1 means number should be negative. Okay, number should be negative. Now we are going to find the characteristic part and the fractional part, C and F. Okay, Mandisa. So first, as I told you, we are marking the positions of the number. Characteristic part this direction, fractional part going this direction. So starting from 0, okay, 1, I am just marking only one number positions. Okay, so 0, 1, this is 2th position. 3rd position we have 1. 4th we have 0, 5th 0, 6th 0, 7, 8, 9, all zeros. Now last 10th position we have 1. Okay, starting from 0 up to 10 always. Now same way fractional part also, only I am representing the 1 numbers. So here this is minus 1th position, minus 2 and minus 3th position we have zeros. Minus 3th position we have number, sorry, not minus 3, minus 4th position we have number, minus 5, minus 6 we have 0, minus 7 and minus 8 position we have 1, remaining all the position we have zeros. So ending minus 52, correct? Totally we have 52 bit. Okay, only just highlight the 1 bit number. So conversion is easy to you. Okay, now first we are writing what is the characteristic part. So starting from here 1 multiply 2 power position of the number. So I am not writing 1 here this question. Okay, let us practice like that. So 2 power position of the number is 10 plus next one here 1 multiply 2 power position of the number is 3 plus here also 1 multiply 2 power position of the number is 1. So that you are getting from the calculator easily 1034. 1034 is the number. Okay, now we will go to the Mandisa again. So starting from this 1 multiply 2 power minus 1, correct? 1 multiply, no need to write, 2 power minus 1 plus here 2 power minus 4 plus here 2 power minus 7 plus 2 power minus 8, 2 power position of the number. Okay, because of binary we are taking that 2, only we have 2 options 0 and 1, correct? 2 power minus 8. Now equal to, you can calculate this number in your calculator, you will get 0.57421875. Okay, 1875. This is the Mandisa fractional part. Now we are going to find what is the decimal number or decimal equivalent. So decimal number equals, write the rule first, minus 1 power s multiply 2 power c minus 1023 multiply 1 plus f. Okay, now apply the numbers. Equals minus 1 power s means 1 multiply 2 power c number is 1034 minus 1023 multiply 1 plus f is 0.57421875. Okay, now as I told you before entering your calculator, minus 1 power 1 means, what is the meaning? Minus 1 power 1. Power 1 means negative. Only meaning is that number is negative. Already we are mentioned on the top. Okay, so minus. The remaining term completely you can write, enter in your calculator, so that you are getting 3224 minus 3224. This is the decimal number representing that 64-bit machine number. I hope it is clear to you, this question. Okay, well, we'll go to the next question now. Question number 1C part. Question number 1C part. Okay, find the decimal equivalent. Find the decimal number. Find the decimal equivalent of the 64-bit long floating point machine number 0, 0, 1, 1, 1. Now next to 52-bit also given. So we will start with the first bit is 0 here. So s equal to 0. 0 means number should be positive number. Now we are changing the characteristic part and the fractional part, f part. So first we are marking the positions of the number. Characteristic part starting with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th position is 0, correct? Same way the Mandisa part, minus 1th position is 0, minus 2th position we have 1, minus 3 position 0, minus 4th position 1, minus 5 0, minus 6 0, minus 7th position we have number, and minus 8th position we have number. Remaining all the bit are 0 up to minus 52, correct? Totally 52 bit there. Now we are converting the number into decimal number. First characteristic part. starting from here. Okay, so 2 power 9, 1 multiply 2 power 9 plus, there are too many ones are there, all numbers we are changing. Now plus 2 power 8 plus 2 power 7 plus 2 power 6 plus 2 power 5 plus 2 power 4 plus 2 power 3 plus 2 power 2 plus 2 power 1 plus 2 power 0. Correct? All the numbers we are changing. So when you are entering calculator, you will get 1023. 1023 is the decimal number representing the characteristic part. Now we will go to the fractional part in the same way. Okay, starting from the position minus 2 there, 2 power minus 2. Sorry. Okay, yeah, 2 power minus 2 plus, then minus 4th position, 2 power minus 4 plus, then 2 power minus 7 plus 2 power minus 8. Correct? 1 multiply, but 1 multiply we are not writing, easy way, just 2 power the position of the number. So what will be the answer getting? Equals 0.32421875. I hope you are getting the same number from the calculator. Now we will write the decimal number now. Okay, decimal equivalent. Okay, decimal number equals, so what is the rule? Minus 1 power s multiply 2 power c minus 1023 multiply 1 plus f. So apply the number equals minus 1 power, what is s here? 0. Multiply 2 power, what is c here? 1023 minus 1023 multiply 1 plus f number 0.32421875. Okay. Now before entering calculator, I told you minus 1 power 0 means nothing, just number is positive. Correct? Number should be positive. So positive, the remaining terms fully you can enter your calculator, you can check the number. Here see 2 power 1023 minus 1023, that become 2 power 0. 2 power 0 means it is 1. So calculation more easy, 1.32421875. This is the decimal number representing that 64-bit machine number. Okay, I hope you are clear this idea. So from binary number to machine number to decimal number conversion, we did these 3 questions. Okay, now we will go to some other questions. Question number 2. You can see, find the characteristic. Okay, the question is different. Find the characteristic C. That means we need to find what is C value. C equals, using a 64-bit equivalent, decimal number already given, answer already given here. Correct? Decimal number equals 147. Okay, decimal number equal 147, and with Mandisa f also given. What is f here? 0.1484375. Okay, what will be the characteristic part? That is the question here. So this question we are just starting from our rule. Correct? This type of question just start from the rule. You know the decimal number equals minus 1 power s multiply 2 power c minus 1023 multiply 1 plus f. Correct? Now whatever value we know, we can apply here. decimal number already given, so 147 equals minus 1 power. What will be the s here? S is not given, but we can see what is s here. What is s? S is the sign indicator, correct? Here the decimal number is 147, correct? 147 means number is positive number. Yes, number positive means what will be the s value? S value equal to 0, correct? So it is there in the question, but you need to identify what is the s number. So s is 0, multiply 2 power c number, we don't know, we need to find, minus 1023 multiply 1 plus f number 0.1484375. Okay, 1 plus f number. Now just we will simplify that step. Equals 147 equals minus 1 power 0. Okay, what is the meaning of that one? Minus 1 power 0, positive, correct? Meaning is number is positive, correct? Number is positive. So nothing other meaning, minus 1 power 0, number will be positive. So no need to write a positive sign, it is not necessary. So 2 power c minus 1023 multiply 1 plus 0.148, that number means we can add 1.1484375. Clear? Okay. Now see, we need to find the c number from here, correct? So we need to cancel this 1.1484377, correct? Then only we can get its c number. So divide both side by 1.1484375, both sides, okay? 1.1484375, so that we can cancel this term. Okay, so only right hand side, what is balance? 2 power c minus 1023 equal to left hand side, this one you can enter your calculator, so that you will get 128. You will get the number 128. So what we got last? 128 equals 2 power c minus 1023. Okay. Now the remaining steps I will do in the next page. So you can see, okay, we are here, 128 equals 2 power c minus 1023. Okay, now from this we need to find the c number. Now from here we need to find c number. We can use two methods. One of the method you can follow. Okay, so first what you are doing is, think about the number 128. This 128 number, if you can write 2 power something, then calculation will be easy. So you can check your calculator, what is 2 power 6, what is 2 power 7, like. So 128 means 2 power 7, that number. Correctly we can write 2 power 7 equals 2 power c minus 1023. Okay. Now if you are writing like this, finding c is easy here, because the base is 2 here. Here also base 2, correct? Both side base same, 2 is the base. So only just to take the power of that number. Okay. So here power is 7 equals, right hand side power is c minus 1023. Equate the power only. Okay. So that we will get what is the c number. You know how to calculate c from here. Minus 1023 take to next side. So it become 7 plus 1023 minus 1023 coming to left side means plus 1023 equals right hand side only c, so that you will get c number, c equal to 1030. I hope it is clear to you, correct? C equal to 1030. Now this is the first method. Okay, first way we can find like this the c number. I am just writing here method 1. Now you can use another method also, this method 2 for finding c. Just we are last step, we are stopped. 128 equals 2 power c minus 1023, correct? Now, if you cannot write 2 power something 128, if you are not writing 2 power 7 something, sometime the number we cannot write correctly 2 power. So that time we are taking, just take len on both sides. Len of 128 equals len of 2 power c minus 1023. Just apply the logarithm. Okay, len. So what we are getting, len 128 equals, now just apply the property of the logarithm. You know what is the property of the logarithm? Power taking to the front side of the logarithm. Okay, power in the beginning, and len apply to the base number. Okay, so how can we write that one? C minus 1023. Okay, the power we are written first, multiply len of the base number is 2, len of 2. This step is the extra step here. Okay, only one step. Okay, so we will get this step. Now after that we need to find the c number, correct? C minus c number we need to find. So divide both side by len 2, because we need to cancel that len 2, correct? So this len 2 and len 2 will cancel. Okay, now this left side you can check by calculator what is len 128 over len 2. Okay, once you are entering your calculator, you will get it is equal to 7. 7 equal to what will be balance on the right hand side? C minus 1023. See, we are getting the same step here. See, we are reached the same step here. Now from this we can find what is the c number. So minus 1023 take to next side, so that we are getting c equals 7 plus 1023. That means c equals 1030. Okay, so this is method 2. This is also almost same like method 1, only one step only extra coming. And all the question you can use the method 2, any number regardless of 2 power, any question if you are getting, we can use the method 2. So one of the method you can follow for finding c number. So I hope you are clear in the c finding question, how to find the c characteristic part from the question. Okay, now we will go to the next question, question number 3. You can just read question number 3. Find the Mandisa. Okay, find the fractional part f using a 64-bit machine number, sorry, decimal number equivalent. So we need to find f value. Decimal number, decimal equivalent already given. What is the decimal number given? Equal minus 2712. Okay, decimal number, this one. And with characteristic part c equal to 1034. We need to find what is the f number here. Okay, fractional part here. So this question also we are just starting with our rule. Decimal number equals minus 1 power s multiply 2 power c minus 1023 multiply 1 plus f. Okay, just starting from the rule. Now just apply the number, whatever the number given in the question. Decimal number is given minus 2712 equals minus 1 power. What will be s here? S means the sign bit, sign indicator, correct? Here the number you can see, number is a negative number. Yes, decimal number is negative. Number negative means what will be s value? S value should be 1. Okay, so we can write minus 1 power 1 multiply 2 power c number is 1034 minus 1023 multiply 1 plus f value we don't know, we need to find that one, 1 plus f. Now just to go to simplification now, minus 2712 equals, as I told you, minus 1 power 1 means what is the meaning? Negative, correct? We need to put negative sign. Minus 1 power 1 means negative. And just to calculate what is 2 power 1034 minus 1023. What will be the value? 2048 minus 2048 multiply 1 plus f. Multiply 1 plus f. I hope you understood that step. Now we need to calculate f value from here. So both side we need to divide by minus 2048. Correct? Minus 2048, because we need to cancel this number. That is why we are dividing both sides by the same number, minus 2048. So minus will cancel and 2048 will be cancelled. So 1 plus f only balance on the right hand side. So 1 plus f equal to, you can check this number in your calculator, minus 2712 divide minus 2048. Minus also will cancel. So you will get 1.32421875. Correct? Now from this find what is the f number. That means this plus 1 take to the left side. So f equals plus 1 come to the left side means minus 1. So 1.32421875 minus 1. Correct? So you will get what is the f number here. F equals, subtract that, so that you will get 0.32421875. This is the Mandisa in that question. F equals. I hope you understood this question. Okay, Mandisa equals 0.32421875. Okay, now we will go to the next question. Question number 4. Something different question. Write the 64-bit machine number. That is the question. Write the 64-bit machine number when the number is negative and c equal to 1023 and f equal to 1 over 2, 1 over 2 power 3, 1 over 2 power 4 plus 1 over 2 power 6. Write the 64-bit machine number. So actually what is the question? We need to write the 64-bit machine number. Correct? That means we need to write what is the sign bit. We need to write what is the characteristic part and what is the fractional part, f part. Correct? So s means only 1 bit. We need to find that 1 bit. C means we need to find 11-bit binary number. F means we need to calculate 52-bit binary number. Correct? It's totally 64-bit. We need to calculate this one. This is what our question. So we will come to the question. See, you can read. When the number is negative, correct? That means what is the s value? Number negative means s number equal to 1, correct? S value equal to 1 because the number is negative. Okay, so what we can write here in the first bit part, number will be 1. So first bit we got the answer, s equal to 1 here, 1 bit. Okay, now we will go to calculate the characteristic part now. C equal, decimal number is given, characteristic part representing decimal is 1023. Okay, but it is decimal number. We need 11-bit binary from this 1023. Correct? We need to change into binary number, this decimal number. Correct? So how to change that number into 11-bit binary? We will do that one. All of you remember last we changed binary number into decimal number. 2 power the position of the number plus 2 power the position of the number, like, correct? 1 multiply we did. Now if you want a decimal to binary conversion, okay, whatever the decimal number 1023 divided by the number 2, okay, divide. Okay, so I will show here how to find that 11-bit number. 1023 divide by 2. See, first I am doing the calculation, 1 or 2 steps I will show here. 1023 divided by 2, you can check by calculator. What will be the number? 511.5. Okay, now that means 511 times correctly it is going and 0.5 is remaining. 0.5 is remaining number. Okay, so what you will write? 511 we will write here, 511 only the correctly going number. After that 0.5 meaning is 1. Balance is 1. How we are getting this 1? 0.5 multiplied 2. Okay, 0.5 multiplied 2 means it is 1. So 1 is the balance. That remainder number, just put an arrow and write here. Balance is 1. 5, 11, 0.5. Only we have two possibility, either 0.5 or 0, because binary number means 1 or 0, correct? So 0.5 coming time you can write balance is 1, and 1 0 coming time means balance is 0. Okay, now I am continuing that one. 5, 11 again divided by 2. I will show here 5, 11 divided by 2. From the calculator you will get 255.5. Correct? So what we can write that question? 255 times correctly going. So we can write here 255. Now whatever the remainder, write here. What is the remainder here? 0.5. 0.5 means 1. Correct? So I can write here 1. And keep in your mind the first slot here. See, here nothing is there. It is just empty. Starting from the second slot. Okay, first slot is empty. Now again divide by number 2. We will continue. 255 divided by 2. We will get 127.5. So 127 we can write here. 0.5 means 1. Now again 127 divided by 2. 63.5. 63 we are writing here. 0.5 means here 1. Again 63 divided by 2. 31.5. 0.5 means 1 we can write here. Again 31 divided by 2. 15.5. So 15 we can write here. 0.5 means 1. Then again 15 divided by 2. 7.5. 7 we are writing here. 0.5 means 1. Again divided by 2. Okay, 3.5. 3 we will be writing here, and 0.5 means 1. Again 3 divided by 2. 1.5. 1 we will write here. 0.5 means 1 remainder. Correct? 1. Now once you go to 1 you can stop. Okay, this number 1 getting, you can stop. Now we are writing what is the 11-bit number representing this 1023. So just start from here. Start from here. Okay, this is the first number. Okay, not position, first number. This is second, third, 4, 5, 6, 7, 8, 9, 10. Okay, so write here like this. For your better understanding, I am writing like this. Okay, start from here. See how many ones are coming. 10 ones are there. Correct? So first one here, second, 3, 4, 5, 6, 7, 8, 9, 10 ones. Okay, but how many bit we needed? 11 bit. Correct? 11 bit characteristic part. So 1 bit is missing. So that 1 bit you can compensate on the beginning. Just add 0 on the beginning. 0, then next 10. Totally we are getting 11 bit. Okay, totally we are getting 11 bit number. Okay, I hope you understood how to convert that one. Keep in our mind this order we need to write that binary numbers 0, 1, 1, 1 up to that one. Okay, so this is the 11 bit. So I am just marking here that 11 bit number. You can see C part we got first 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. Okay, and 0. So totally 11 bit we are writing. Now lastly we need to convert the fractional part here. Correct? So what is the fractional part here? F equals, okay, 1 over 2 plus 1 over 2 power 3 plus 1 over 2 power 4 plus 1 over 2 power 6. Okay, now for changing this number into binary, first take this number 2 onto the top. 2 power 3 take to the numerator. 2 power 4, 2 power 6 all take to the numerator, because 2 power position, like that we are writing the conversion time. Correct? So 1 over 2 2 coming upside means 2 power minus 1 plus 2 power 3, take it up, 2 power minus 3 plus 2 power 4 becomes 2 power minus 4 plus 2 power 6 becomes 2 power minus 6. Take it upside all the numbers. That means the 2 power position of the number, minus 1th position, 2 power minus 3th position, 2 power minus 4th position, 2 power minus 6th position, correct? Now, you remember how we are marking the position of the fractional part. How we are marking starting from minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, like that last minus 52, correct? 52 bit fractional part. So, what we are getting here, what is our fractional part? 2 power minus 1 plus 2 power minus 3 plus 2 power minus 4 plus 2 power minus 6. Okay. Now, I am just marking these numbers here. You can see how we will write into the 52-bit format. See, 2 power minus 1. That means minus 1th position, just write 1. Minus 1th position, we have a 1 bit. Okay. So, 1 number. So, write 1. Minus 2, we don't have number here. So, just write 0. Correct. Minus 2, we don't have the number. So, write 0. Now, minus 3, see 2 power minus 3, that means we have minus 3th position. So, minus 3th position, we can write 1. Now, here minus 4th position, we have number. So, write minus 4th position also 1. Minus 5th position, we don't have number. So, write 0. And minus 6th position, we have number. So, we can write number 1. And remaining all other positions, we can write 0. Okay, up to the last 52 bit, we can put zeros. So, this is the idea for converting the fractional part. Okay, only check the position. If that position coming, put 1. If that position not coming means we need to write 0. Okay, all other positions. So, this is the 64-bit binary representation of that question. Okay, 1 bit, then 11 bit, then 52 bit, totally 64 bit representation. Okay, in this case number is negative, C 1023 and F part. Okay, we are changed all into the binary number. I hope you understood this question. Okay, now we will go to the next question. Question number 5. Convert the following decimal number into 11-bit binary number. What is the question? Convert. What we need to convert? Decimal number into 11-bit binary number. Okay, we did here, you remember. See, in the characteristic part, we converted into 11-bit number, correct? So, this only we need to practice here. Convert the 11-bit binary number. The decimal number is 1013. 1013 we need to convert into 11-bit binary number. So, same idea whatever we did before question. So, we will do here 1013 divide by 2, correct? So, we can write here also 1013 divide by 2, you will get 506.5. So, what we need to write? Correctly 506 time, we write here 506. Okay, remainder 0.5 means what will be the remainder? 1. Okay, so we can write 1 here. 0.5 means 1. Okay, as I told you, first portion is empty, nothing is there. Second portion only we are starting. Now again divide this number by 2. 506 divide 2. What is the number? 253. Correct? 253 means 253.0. There is no decimal part, fraction part. Okay. So how to write that number? 253 times correctly going. So 253 I can write here. What will be the remainder? 0 means we need to write 0 as the remainder. Okay, so we can write 0. I hope you understood the conversion. Now continue up to the end. Now 253 divided 2. What is 253 divided to 126.5? 0.5 means 1 balance. Then 126 divided by 2, 63.0. 63 only, correct? So balance is 0. Again divide by 2, 63 divided by 2 means 31.5. 0.5 we can write 1. Again 31 divided by 2, 15.5. So we can write 0.5 means 1. Again 15 divided by 2, 7.5. So 7.5 means 1. Again divide 2, 3.5. So 3 we can write here. 0.5 we can write 1. Again 3 divided 2, 1.5. 1 we can write here. 0.5 means 1 balance. Correct? Now once we got 1, we can stop. Now we will write the answer starting from here. Okay, this is the first one. Second, third, fourth, fifth, sixth, 7, 8, 9, 10. Okay, so this direction. Okay, so we can mark like first number is 1. How many ones are there starting? 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay, then 0, then 1, 0, 1. Correct? So totally we have 10 bit we are getting. But how many bit we needed? 11 bit. Correct? 11 bit binary. So what we need to do? Add 0 on the beginning. Beginning we are writing 1, 0. So this will be totally 11 bit number, 11 bit. Okay, so when we are writing, you can careful. Okay, starting this number we are added number 0. Okay, and all other number write this order, this direction. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like this. Okay, this order we can write. This is not the position, just write that order. Okay, so this is the 11 bit number. I hope you understood this question. Now same model, one more question we can practice. See question number 5b. Convert the decimal number into 11 bit binary number. Correct? 1027 is the number. 1027. So we will start again. 1027 can divide by 2. Okay. So 1027 divided by 2 means 513.5. 0.5 means we can write 1 here. As I told you, first part is empty, nothing. Now 513 divided 2. What is 513 divided 2? 256.5. Correct? 0.5 means remainder is 1. Again divide by 2, 128, no remainder because 0. Again 128 divided by 2, 64. Okay, remainder is 0. Again 64 divided 2, 32 from the calculator, that means remainder is 0. Again 32 divided 2, 16. Remainder is 0. Again 16 over 2, 8 times. Remainder is 0. Again 8 divided 2, 4 times. Remainder is 0. And 4 divided 2, 2 times. Remainder is 0. Again 2 divided 2, 1 times. Remainder is 0. Don't forget this bit. Okay. Remainder is 0. Now we can stop here once you go to 1. Now we are writing the answer starting from here. This is the first one, second, third, 4, 5, 6, 7, 8, 9, 10 and 11. Okay, so we can write the answer starting 1. Then how many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros. Then 1, 1. Correct? So totally how many bit we are getting? 8 plus 2 plus 1, 11 bit. Okay, so totally from that answer we got already 11 bit, so no need to add anything here. If it is less than 11 bit only, we are adding 0 on the beginning. Correct? So here already we have 11 bit, so nothing to add. That is the 11 bit number, 11 bit representation of that decimal number 1027. Now, okay, this question we can do directly from our calculator. For checking purpose, you can use the calculator. I will show the steps how we are doing this 11 bit finding from the calculator. Okay, for example, the same question 1027. I will show by calculator here. You can see what you do in your calculator. I will show in step by step. First, you can press the mode button. Okay. After that, you can see in your computer calculator display, you can see this option base n, like this one option will come, that is number 4, fourth option, fourth number. Base n means in that calculator whatever we are using, we can convert into binary number, hexal, octal conversion, everything is there. Okay, base, okay, n. Now choose that option. Then your calculator by default, you can see like that, decimal 0, default decimal will come, decimal 0, we are not entered any number. Now just enter your number 1027, just enter and press equal to, so that your display calculator will get like this 1027. Just enter whatever the number 1027, that number you are entering, press equal to. Okay, so that your display is showing like this decimal 1027. Now after what we will do is just press shift button, okay, and log button after that, shift log. Why we are pressing shift log? Because here, see here yellow color you can see by bin binary number. Okay, because we need to convert this into binary number. So for getting this yellow color only we are using shift button. Okay, so shift log. So your calculator will get what is the binary number like this 0 0 0 0 0, then 1 1 2 3 4 5 6 7 8 1 1. Your calculator display, it will show like this bin binary 0 0 0 1 0 0 up to that last number. Correct? Now from this you can select your answer, last 11 bit select. Okay, select last 11 bit. Okay, because we need 11 bit conversion. Correct? So last 11 bit we can choose. This is the binary number representing that 1027, 11 bit binary number representing that decimal number. So in the question, do these 3 steps. Okay, this one we can say step 1, just select the mode, base n number 4, then decimal number enter. After that in the step 2, shift log button, so it will come binary shift log, one green color. Okay, green color button you can see bin, so you will get that number. Now step 3, you will got the answer, select your 11 bit number like this. Okay, select your 11 bit number, so that you are getting binary number. Same way you can convert octal, okay, and hexal, all conversions are there in your calculator. Okay, you can see green color, decimal, hex, bin, oct, like that in your calculator. Okay, now see, this is the easier way for checking the answer correct or not in from calculator. Now once you finish your calculator, you can return back your same mode. Okay, so for that just press the mode button. and number 1. Select number 1. This is the return mode. Okay. To return back to the calculator, same, you can use mode 1. Mode 1 means it is the computation mode. That is the default mode we are using for the calculation purpose. So mode 1. So that will return in the same screen. Okay. I hope you understood how to find the 11-bit number from the calculator. Okay. We will go to one more question. Question number 5. You can read this question. This is important question. From the 64-bit machine number. Okay. From the 64-bit machine number, one machine number is given. You can see the machine number there. 0, 1, 0, 0 like that. Then 52-bit. What is the question? Write next largest machine number and next smallest machine number. Next largest machine number, next smallest machine number. Okay. So what it means actually, see here, this is the 64-bit machine number. 0 and 11-bit, next 52-bit. Now when we are converting this number into decimal number, you will get this number 3224. 3224. Okay. Just telling the answer only. What is the number converting time? We are getting 3224. This is the number, decimal number. Okay. Now what is our question actually? What will be the next largest machine number? Okay. Next largest machine number. And what will be the next smallest machine number? Okay. Next smallest machine number. What it means actually? What will be the computer taking next number as a next number after 3224? What will be the next number in the 64-bit computer? That is the meaning next largest machine number. Okay. And what will be next smallest means just before what will be the number, smallest number. Okay. Computer will take 3224 before. What will be the number computer will take? This is the meaning next largest and next smallest. This is what we are calling machine precision. How much accurately a number we can represent in a 64-bit computer. Machine precision. Okay. See, I wrote the answer here. Next largest machine number in 64-bit computer will be 3224.0000454744735. Okay. We cannot find that manually. I'm just writing the number here. We don't want that number. Okay, because our question is find the next largest machine number format. Okay, we don't want that decimal number. But for your understanding, I wrote next largest number means after 3224. Computer will take next number as 3224000. See how many zeros? How many zeros are there? More zeros are there. That means numbers we can represent very accurately in 64-bit computer. Correct? So what will be the next largest machine number? 3224.0000, that number. Now next smallest machine number means before this number. What will be the number? After and before. Before means smallest. See 3224 before. What will be the number representing in 64-bit computer? See the number, answer I already wrote here in decimal format. See, this is that number. 3223.999999 like that. Okay, very small difference. Okay, so what we need to do in this question is next largest machine number we need to write in the machine format. Okay, that means the binary format. And next smallest machine number also we need to write in the binary format. So I will tell you the idea first here. If you want next largest machine number. Okay, if you want next largest machine number, what we will do here, this question. Okay, this question, S part we will write same, this sign bit part. Okay, and C part also we are writing same. Okay, I will write here same. C part also we are writing same. But when we are changing fractional part to something, we will get next largest machine number. What we will do in the fractional part is that in the fractional 52-bit part, wherever the last 0 coming, change that number into 1. This is the idea for getting next largest machine number. Last 0 bit, okay? Last 0 bit in the fractional part, change into 1. Okay? For example, you can see this question, our question. See, I am writing the answer here, next largest machine number here. First bit is 0. See, no change here, 0. Next 11 bit also, we are writing same here. 11 bit number same. Now next 52 bit part, okay, what I told actually, last 0 change into 1. See, where is the last 0 coming? You can check it, 0 0. Here is the last 0. This 0 you need to change into 1. All other same. See, 1 0 0, 1 0 0, 1 1 0 0 0. Last 0 only change into 1. So that you are getting the next largest machine number. Okay, that means you will get the answer 3224.00045474735, that number. I hope you understood how to find the next largest machine number. That means S part same, C part same, fractional part only, last 0 change into 1. Now I will go to the next smallest machine number. Okay, next smallest machine number. You can see how can we find the next smallest machine number from that question. Write the sign bit part same, just same as before, and characteristic part also we are writing same. Only the fractional part, when we are changing something in the fractional part, okay, F part, we will get the next smallest machine number. So what we need to do is just check last 1, binary number 1, last 1 in the fractional part, change into 0. Okay, change that 1 into 0, last 1. I will show in the example. But before that, we need to know how to do that one. Last binary number 1, change into 0. After that, after this binary number 1, okay, after 1, after the binary number 1, all zeros, okay, whatever, how many zeros are coming, all zeros change into 1. All zeros change into 1. After 1 only, after this 1, okay, after that number 1. Keep in our mind, after this number 1, all the zeros change into 1. Before 1, don't change. After 1, how many zeros? That all zeros change into 1. So that you will get next smallest machine number. For example, here in this question, you can see. So first bit part, we will go to the smallest machine number. First bit 0. Here also same 0. Next 11 bit, we are written same 11 bit. Okay. Now fractional part I told you, last 1. See, here is the last one. Last one here. So 1 0 0, 1 0 0 and 1. Next one, last one, that number we need to change into 0. Correct? Then after this one, all zeros. So that means this 0, here 0, here, here, here and here. All the zeros change into 1. See, here all the zeros after that number 1 changed into 1. Before 0 don't change, it is same. After that number 1, zeros changed into 1. This is the method to find the next smallest machine number. So that you are getting 3223.999 this number. Okay. So machine precision, this question is very important, especially IT related students. Okay. How to find the machine precision. Next smallest, next is largest machine number. So this is the idea in the topic 1.2, the machine number. I hope you understood all the ideas whatever we discussed here, the questions. Okay, so next video we will go to 1.3 section, okay, in detail. So once again thank you for watching, and please subscribe my channel for getting more recorded classes and the workshop, some software related workshops, all you can download from our channel. So thank you again, thank you for watching.